Does anybody remember the acronym that goes with right triangle trigonometry? Ben? SOHCAHTOA. That is what we're going to be dealing with today. All right. So SOHCAHTOA. Okay, but we're going to add a little bit more to it. We're going to add 3 more functions to sine, cosine, and tangent, but it's not going to be hard, I promise. All right. So, okay. All right. It just focuses and it sees something and moves. Okay. So, I'm not going to review that much with you with that. Let's just start with an angle, or a triangle, I should say. Let's suppose that I got a side here, a leg of a right triangle that's 2 units long, and the hypotenuse is 4 units long, and I'm going to put an angle right here called theta, which we'll be using a lot. Now, we're going to find some trig functions. Okay, just using the SOHCAHTOA. What would the sine of theta be? Yes, say again? 2 over 4. Okay, and we'll simplify anytime we have a chance. We're going to simplify, okay? And if we have radicals, we're going to rationalize the denominators. Everybody clear on that? Okay. Now, do we have enough information right now as it is to have the cosine of theta? No. I'm seeing some no's here. What are you going to do? Pythagorean theorem. Good. Good. If we kind of call this x right now, it's 2 squared plus x squared equals 4 squared, which is 4 plus x squared equals 16. I'm going to subtract 4 here. I have x squared equals 12. What do I need to do now? Square root. Okay, we're doing exact. We're going to do everything exact right now. So I'm not going to just press it in the calculator and see, I don't know, 3 point something or other. Okay, and I'm also excluding the negative root because we're talking about the length of a side of a triangle. So does anybody have that simplified? I know what square root of 12 simplified is? 2 square root of 3, correct. Okay, so x is 2 square root of 3. 2 radical 3 is also a way of saying it. So, cosine of theta then. What are we going to call it? Annie? 2 radical 3 over 4, correct. And if I simplify that a little bit, Maggie?
No, I was asking.
Go ahead.
Why don't you do the positive and the minus?
Why did I not do it?
Yeah.
Okay, that's a good question. In this particular application or context, we're talking about the side of a triangle.
Okay.
So I just kind of ignored the negative part. You are right. This equation has 2 solutions. Positive 2 radical 3 and negative 2 radical 3. But for the problem, the positive is the only one that we need. Okay, very good. And if I simplify this, it's radical 3 over 2. Okay? And then we have the tangent of theta. What's the tangent of theta here? Pardon? 1. Okay, well, I'm going to put it in the first form. So it would be 2 over 2 radical 3, which is 1 over radical 3. Now let's be careful here. When you said 1 over radical 3, you were correct. That's not equal to radical 3, though, is it? Is it in simplified form? We did a little simplifying. We need to, remember the term, blank the denominator. Careful. Rationalize the denominator. So we're going to go square root of 3 over square root of 3. The tangent of theta, 1, oops, this is equals. Okay, 1, that's radical 3 over 3. Everybody good there for the tangent of theta? Okay, we have 3 more functions. These are called not inverse. It's different. These are called reciprocal functions. Okay, reciprocal functions. And they are secant of theta. That is equal to the reciprocal of cosine theta. I wish I'd have started. Never mind. Okay. Okay. Let me write them out in words here. I have secant. It is the reciprocal of cosine. I have cosecant. It is the reciprocal of sine. And I have cotangent. It is the reciprocal of tangent. And I do want you to be careful here, right here. This is, I remember the first time seeing this, I think I've got them backwards. This has cosine. This just has secant. This has just sine, but it has cosecant. Okay? So these two don't go together, and these two don't go together. Is everybody clear on that? So they are reciprocal. So secant of theta equals 1 over cosine theta. Cosecant of theta, we use CSC for cosecant. That's 1 over sine theta. And cotangent of theta, that's 1 over tangent of theta. So when it says find the 6 trig functions, which your instructions will say, we need 3 more in this. And so let's go for cosecant of theta. What's cosecant of theta? It's a reciprocal of what the sine of theta was. It is 2. Is everybody good with that? Reciprocal of 1/2 is 2, right? Yes.
To the right of, under where it says reciprocal functions, what does that say? It's C to the right one.
To the right.
Yeah, sec, and then you have CSC.
Okay. Oh, right here?
Yeah.
Okay. CSC, yeah. I tend to write cursive when I write the trig functions. Yes. The reciprocal is not the inverse. Now, reciprocal is a multiplicative inverse, but this is trig we're dealing with. So it is a reciprocal function. It's not the inverse function. And I think you guys are used to inverse functions, right? If you had to find an angle, you would use an inverse function. 2 different things. And that's a very good point to bring up. Okay? All right, nice. That's good. Thank you. Cosecant of theta is 2. What is the secant of theta? Remember, cosine is this. What would be the secant? Annie? 2 over square root of 3. Is this simplified like we like it? Not with that radical in the denominator, so let's just rationalize the denominator. Let's multiply by the square root of 3 over the square root of 3, right? I got 2 radical 3 over 3. So that's our, this isn't incorrect, but this is the simplified version that we're going to, okay? And then let's do one more. Let's do the cotangent of theta. What's the cotangent of theta here? Now, I would encourage you, we have two answers here. We got this one before it was simplified, and we got this one after it was simplified. Which one do you think would be the easiest to find the reciprocal of? Annie? The unsimplified? The simplified? Okay, how many agree with her? I'll do it. Well, it's all right. It'll work either way. If you do 1 over radical 3, what's the reciprocal of 1 over radical 3? Radical 3 over 1, or just radical 3. Okay? That was kind of a trick question. But all right. Sine, cosine, tangent, cosecant, secant, and cotangent. We've got the 6 trig functions of angle theta in this triangle. Is everybody good with that? Yes, Ryan? Okay. All right. Any questions? Let's just kind of do one more. This time I'm not going to draw a triangle. Let's see, but the sine of theta is 3/5. Find the other 5 trig functions. This is all I'm giving you right now. Any thoughts? How to approach this? Justin? Draw a triangle? Okay, I'll do that. What do you, theta right here? Okay. What can we mark here? Ella? This side? 3's here? Okay. What else? Brian? 5 is the hypotenuse. You want to do anything before we get really into it? Dig down into this? Ben? Okay. So 3 squared plus x squared equals 5 squared. And 9 plus x squared equals 25. Well, this is not going to be bad. Subtract 9, you got x squared is 16. When you take square root, what's x? 4. Ever hear of Pythagorean triples? I think this is the most basic of them. The 3, 4, 5 triangle is a Pythagorean triple. All right, cosine of theta. What is it, Christina? Now that I interrupted you, but now that we've found that the adjacent side is 4, and I asked for cosine of theta. 4 over 5, very good. Tangent of theta. Lexi. Mm, 3/4, everybody good with that? All right, Murphy, what is the, let's go cosecant of theta. This is a new one. Cosecant, let's look. Let's look on the other side here. Cosecant is the reciprocal of sine. Yes, it is. It's 5/3. All right, good. Secant of theta, Cade?
That would be 5/4.
5/4 is correct. And cotangent of theta, Annie? 4/3 is correct. All right, you guys good? This is kind of what it looks like today. That's all the further we're going to delve into right triangle trig today. All right. Miss Sawyer will be in charge of the rest of this. Now, on page 441, I'm going to stop this.